All right, now let's look at another situation here. So if you look at these two inequalities we have 2x plus y is greater than or equal to 2, and we have 2x plus y is less than or equal to 4. So before we even graph this, if you look at this, you should kind of recognize that there's something kind of different going on with this, because we have the exact same thing on the left side on both of these, right? We've got 2x plus y in the top one and 2x plus y in the bottom one. And in each case, they are relating to the number on the other side differently, and they're different numbers. So if you remember this, right, basically what we're going to have is we're going to have parallel lines that that we then need to interpret and see, okay, what's going on with this. So let's start by drawing the lines rather than all this conjecture and everything. But I want you to recognize that when you see something like this and they look exactly the same, basically for maybe some minor differences, it's not unlikely that you're going to get one of these two different special cases, right? Because the other examples we've done gave us like an area that was like one area of a solution, right? So what about infinite numbers of solutions or no solution? And that's kind of what we're going to look at in these next two videos. So let's plot this. So I'm going to take this top equation here and I'm going to plot this using, let's just rewrite it. Okay, so to rewrite it, let's move this 2x over. Okay, so we'll go y is greater than or equal to negative 2x. Remember, when you move it over, it changes its sign. And because I'm moving it over with adding or subtracting, I don't have to flip anything, right? We're in good shape. So we got negative 2x plus 2, which means that this is my y-intercept, right? And then this negative 2 is my slope. Okay, so my y-intercept is 2, so we'll put a point at 2. My slope is negative 2, so that means negative 2 down, and then 1 over to the right. So negative 2 down, 1 over to the right. This is going to be a solid line, and let's just draw it and deal with it, right? So actually, that's not too shabby. Okay, let's shade this thing. So let's put 0, 0 in and see what we get. Let's use yellow first. So if I put 0, 0 in this equation right here, right, you get 0 plus 0 is greater than or equal to 2. That is absolutely false. So we are not going to shade the side that has 0, 0. Instead, we're going to shade the other side, the opposite side. So if it makes the statement false, you shade the other side. If it makes the statement true, you shade that side that has the point that you tested in. As you guys know, I'm lazy and like to use the origin as much as possible. All right, let's do this one right here. Let's do this using intercepts. So to find my x-intercept, I'm going to make y equal to 0, right? That's how we do it. And so you get 2x plus 0, 4, right? Get rid of that. You get 2x less than or equal to 4 divided by 2. You get x. And remember, we're just doing intercepts, so we're not worried about this. Just treat that like an equal sign. So x equals 2. So that is going to be right here at this point. Okay. Now, for my y-intercept, I'm going to make x equal to 0, because that's just how we do that. So we have 2 times 0 plus y is less than or equal to 4. So we're going to get y is less than or equal to 4. So let's go up to 4. Let's put a point. And then that's going to be dashed. So we got this kind of thing going on here. Right? So now, to figure out how to shade this one, let's switch colors. Let's go to orange. Let's put 0, 0 in. So if I put 0 in here, right, it becomes 0. This becomes 0. So you have basically 0 is less than or equal to 4, which we know is true. So on this one, we're going to shade everything underneath this, right? And so now this again gives us an interesting situation where you got to look at this and you got to say, okay, where is the shared area? Well, the shared area, because it's a system, is this stuff all right in here, right? That's our shared area. And so we would get rid of everything else, right? And we would just leave that area shaded. And so, I could make it nice and not look like a big mass of barbed wire there. So that is my solution. So when we interpret this, right, we would say that my solution set is going to give me this little like strip between parallel. So it's if you think about it, any kind of solution where there is a solution for a system of inequalities is an infinite number of possibilities, right? So for this one, we wouldn't write infinite number of solutions because that's the case for all of them that have solutions, all right? And so now for our last case, well, actually, you know what? For our last case, we're going to have another video. So I'm going to stop the video here, and we'll pick it up on the next one.